Right, so now 10E question 4. So two boxes A and B of masses 110 kilograms and 190 kilograms sit on the floor of a lift of mass 1,700 kilograms. Box A sits on top of box B. The lift is supported by a light inextensible cable. Let's just make that. And is descending with a constant acceleration of 1.8 meters per second squared. So let's draw this. So there's my lift, and then you've got box A on top of box B. I'll make my box B a little bit bigger. So there's box A on top of box B. Box A has a mass of 110 kilograms. Box B has a mass of 190 kilograms. And the lift has a weight of 1,700 G. It's connected by a string. There's no straw string there, so it doesn't come in the way of the question. Sorry, a cable, and so there's going to be a tension in the cable. Let's just make that look like a T. And it's descending with a constant acceleration of 1.8 meters per second squared. And we also need to put some other forces on. Now, because A doesn't go through B, it doesn't go into B, so therefore B must be pushing up onto A. So there must be a reaction on A. And likewise, B doesn't go through the lift. So the lift must be pushing up on B. Notice that it's a good time to mention Newton's third law, which says that every force has an equal and opposite reaction of force. So this RA, the reaction on A, must be the same force that A is exerting on B. And this RB must be the same force that B is exerting on the lift. So B is pushing down on the lift by a force equivalent to RB. Okay, now let's see. The question says, find the tension in the string. Tension in the cable, sorry, I keep saying string. Now, when you don't want to do this kind of question, let's just imagine that you treat the whole thing as a system, to treat the whole system together. So you've got the whole thing going down at 1.8 meters per second squared. It's being pulled up by a cable, and the total weight of this whole system is 2,000 G. So this is when you combine all the particles together, like in a pulleys question or a connected particles question. You combine it all together and they've got a total weight of 2,000 G, and they're all accelerating downwards at 1.8 meters per second squared. So now let's apply Newton's second law, which says force is equal to mass times acceleration. I'm going to take downwards as positive, so I don't need an equals, I need a colon there. So it's 2,000 G going down, tension pulling it back up, and that's equal to mass times acceleration. And rearranging that, you should get tension as 16,000 newtons. Right, so that one's okay. Now find the force exerted by box B on box A. So the force exerted by box B on box A. So that's going to be this force here. That's what they're telling us to find. Telling us to find RA. So let's draw box A. So box A has a weight on 110. It's accelerating to the ground at 1.8, and it's also being pushed up by particle B, by box B, but with a force of RA. So that's everything that's acting on A. itself, and that's all the forces that belong to A. So let's do the resultant. Again, let's take downwards as positive. There's 110 G going down. That's the weight component. Take away RA, which is how much box B is pushing box A up, and that's equal to mass times acceleration. So that's just, this is using F equals ma again, and this on this side is our net force. Okay, so if you rearrange, and you can start subbing in 9.8 there. And that's going to be equal to RA. If you whack that into the calculator, you should get RA as 880. And which way is that acting? That's going to be acting in an upward direction. So that's the force exerted on box A by box B. The next part said, find the force exerted by box B on the floor of the lift. So as I said earlier, we're being asked to find out what RB is. But as I said earlier, that force that the lift exerts on B is the same as the force B exerts on the lift itself. Okay? Because of Newton's third law equal and opposite reaction force. So RB, which is the force exerted by the lift on box B, is the same as the force exerted by the box on the lift. And in order to answer this, I'm going to look at the lift. Generally in these kind of questions, it's best to avoid box B and looking at box B. So the lift, just the lift, has a tension from the cable. Just the lift has a mass of 1,700. So the weight is 1,700 G. And just the lift is being pushed by this force from box B. So looking at just the lift, and the lift is accelerating to the ground, downwards at 1.8 meters per second squared. So if we do F equals ma again, we've got 1,700 G going down. We've also got this RB, reaction from B, going down, and then we've got the tension going up. And that's all equal to 1,700 mass times acceleration. And we know what T was. T was 16,000. So you can sub that in at this stage. And so RB is going to be equal to 2,400. So I just write a little thing. What I did is I made RB the subject. And it comes out to 2,400, and this is acting downwards because the box B is pushing down on the lift, so this is acting downwards. Right, and that's the end of that question. Okay, thanks for listening.